So when I was talking in the previous video about using SHA-1 in a slightly different manner to make it more secure, I was talking about HMACs or hashed keyed message authentication system. So what happens in a HMAC is, if we take two examples, it would be easier to understand. So if there was Alice and Bob, and Alice is trying to send something to Bob, it's not a problem, right? But what if a hacker is sitting in the middle? So everything that Alice and Bob sends or receives is passing through the hacker's computer, right? So what the hacker can do, he can alter the message that Bob is sending to Alice or Alice is sending to Bob. And that can cause trouble, right? So Alice and Bob started using hashing. This process is called message authentication system without the H. So in a message authentication system, what they does is when Bob is trying to send something to Alice, Bob is taking the message and hashing it, maybe with SHA-1 for example, and then he is sending to Alice both the message and the hash. Now what happens, Alice takes the message which Bob sent her and recomputing the same SHA-1 hash for the message. Now if the hash which Bob sent and if the hash which Alice generated are identical, then Alice can know that the message has not been tampered with. But what the hacker can do in the middle is that the hacker can actually alter the text or alter the message and then recompute a SHA-1 hash of that altered text and send that to Bob or Alice. Now Alice can again recompute the hash for the message and she will exactly recompute the same exact hash that the hacker made, because the message is not secured, the hash is not secured, because it's a plain simple hash of a message which Alice is receiving. So if the message that Alice is receiving is from the hacker and the hacker also computed the hash for the message that he sent to Alice, then Alice is also going to get the same resulting hash, right? So this is also a problem, and thus using message authentication code in this scenario wasn't very much secure. So that's why hashed message authentication was introduced. So what hashed message authentication does is it uses a pre-shared key mechanism. So what in this case, in this example happens is, maybe Bob and Alice figured out that there is a hacker. So what they did, they called each other up and they agreed on a password. Maybe in this case it's hello. So they agreed on the pre-shared key and they keep that key to themselves. They do not say that to anybody, right? Only the two communicating parties know this key. Now what they will do is they will use that key and perform an HMAC operation. I'm going to be discussing this in this part when I'm explaining this, but for just now, let's say that he is going to compute the hash along with the key and send the message and the hash to Alice. Alice also knows the pre-shared key, and Alice can also recompute the same thing using her own key and get the resulting hash back. So if the resulting hash is equal to the hash that Bob sent, then they can be 100% sure of that the data is not being tampered with. Why? Because in this scenario, the hacker is the only one who doesn't know the pre-shared key, right? And the pre-shared key is an utmost necessary in computing the hash in case of HMAC. So how HMAC works? Let's see here. What Alice or Bob does is, in this HMAC operation, they take the message and append it to the key. Then they hash the appended version of the key and message with maybe SHA-1. Again, the resulting hash is appended to the same key and the whole thing is hashed again, thus making HMAC very secure. So the hash that we get is very much abstract from what the actual key or what the actual message was, because again, if I say M represents the message, K represents the key, and I'm not going to be going in much details, but these two keys are not exactly same, but they are both derived from the same key. This key is actually called the inner key, which is XORed with something called inner pad, which is a value I'm not going to talk about, but just let's remember this one now. Then this key is the outer key, which is XORed with an outer pad. So that's how a same key, which is in this case hello, is going to be yielding different keys for both the values. So what happens is they take the message and append it to the inner key and hash it. Then the resulting hash is appended to the outer key, and then again the whole thing is hashed with the same hashing algorithm. So now when they send this resulting hash from the whole operation along with the message to for example, Alice is going to perform the same thing because she also knows the pre-shared key, right? So when Alice does the same thing, and if the resulting hash is exactly identical to the hash that Bob sent, they can be 100% sure of that the data has not been altered, because the hacker cannot know what the key was. So the hacker cannot recompute the new HMAC hash because he doesn't know the key. So that's how Alice and Bob can be very sure that the data which they receive are not being tampered with. So now we know the use and how HMAC works and how HMAC is computed. So let's move on to the next chapter.